So thank you for that nice introduction, Andrew. As you said, I am the product manager for safety laser scanners at SICK. So what I want to talk to you about today is the brand new NanoScan 3 safety laser scanner. So this is the latest and greatest from SICK. This launched toward the beginning of this year. And the first thing that probably jumps out to you is the ultra small size of this ultra small size of this scanner. I actually conveniently have a micro scan here. This is a microscan Ethernet IP scanner, which can be integrated into SIP safety networks. But you can see here the side-by-side comparison. The NanoScan actually fits basically into the base of the microscan. So very, very low profile scanner. This is especially useful in situations where you might have some tight spaces that you need to fit a scanner into. This is a really big deal for smaller AGVs and AGCs, so mobile vehicles where you really want to save space. And another really nice thing about this for those mobile applications is you can actually bring encoder signals directly into the scanner for speed recognition. So as the vehicle's changing speed, we can send those signals back to the scanner and then change our fields per the speed of the vehicle. So as the vehicle speeds up, we're going to want to look out further because that's going to increase our stopping time. And as the vehicle slows down, we can bring those fields in closer. And of course, there are also static inputs on this scanner too. So you're able to determine position of wheels, for example. So if a wheel is turning left or right or straight, we can also tell the scanner that, so we can adjust our fields based on that information. So now as we look at the scanner, I just want to kind of walk you through it a little bit. You'll see that on the front screen, we have a highly visible LCD display, which shows you the status of the scanner. So we have a green check mark right now telling us that there is no field infringed. But if I put my hand out here in the way, you can see that it turns yellow with a little caution sign telling me that I'm in the warning field. As I come closer into the protective field, we go red with a red X in there saying that there is an object or a person inside the protective field, and now the safe outputs have gone low. So as we kind of walk around the NanoScan here, we have on each side 2 mounting holes. That's for the brackets that are available. We have just standard brackets that offer no adjustment. We have a bracket that offers some pitch and yaw adjustment, and then also both of those with an overhead protective plate available. So 4 different bracket options there. And then something very, very cool about the NanoScan, and it is really true of nearly all of SICK's safety laser scanners. I think it's about 98% of our portfolio, is we have this system plug that plugs into the scanner, and the system plug actually holds the configuration memory. So if the scanner is ever damaged to a point where it just doesn't work any longer, you can actually pop off the system plug, get a new scanner head, put that system plug onto the new scanner head, and you are up and running because that configuration was saved in the system plug. So no need to connect with a laptop to do any reconfiguration or send that saved configuration into the new scanner. It's all up and running, and those system connections are made to the system plug, so you don't have to worry about doing any rewiring or buying new cabling or doing anything like that. So that's very nice. This also has an option for Ethernet output. We have multiple different system plug options available, so you can get that with or without Ethernet. It's up to you. If you get it with the Ethernet, the system plug will have another pigtail coming out of it and that nice Ethernet green, so you know that that's your Ethernet connection. That's just an M12 4-pin decoded connector. So you can connect up to that and take that back to a PLC, send information to an HMI. Otherwise, you can also get your measurement data out of that. So that's very important to note too. Protective field on this has a long range of 3 meters. So very, very small scanner. We have a long range of 3 meters on the protective field, but that measurement data that I mentioned, you actually get that out to 40 meters. That's 40 meters. So if you want to use this little scanner on a vehicle for safety purposes, just know that you can also use it for navigation purposes because you get very, very high quality measurement data. Now, what enables us to get that very, very high quality measurement data, higher quality than you'll see on really any other safety laser scanner out there, not including the microscan. So both of these have the same scanning technology. So all of the benefits I talk about the scanning technology for the NanoScan, you're going to get that for the microscan as well. But what enables that high quality scanning technology is a patented SICK technology called Safe HDDM. That stands for Safe High Definition Distance Measurement. In a conventional safety laser scanner, it will take about 500 pulses of data per rotation of the laser. So every time that laser is spinning around, looking out and surveying the area, a conventional scanner will take 500 data measurements. With Safe HDDM, we've increased that to over 80,000 pulses. So we're getting a lot more data into the scanner. But that's not the only thing. So more data is good, but it's not great unless you do something smart with it. So there are built-in algorithms into the scanner to help it filter out things like dust and dirt and ambient light and crosstalk from other scanners or other optical devices. So Safe HDM gives you a much more accurate, precise, and smooth measurement data, but also allows you to reduce false trips due to, like I said, things like debris falling through the air, dust falling through the air, or even building up on the screen. We've seen that as, you know, in dusty environments, we can get a lot of dust buildup on that screen and still work thanks to that Safe HDDM scanning technology. And again, that also enables your much more highly accurate and precise measurement data for your navigation purposes. So multi-purpose scanner that can help you reduce the number of overall sensors on your robot or vehicle, mobile robot, if you will. One other thing I want to point out for enunciation, so we talked about the highly visible LCD display. There are also nice LEDs that are on the top, on the collar of the device. So when it's green, you'll see green on the 3 different sides of the scanner. If we infringe the warning field, you'll see green and yellow. And if we infringe the protective field and the warning field, you'll see red and yellow. So again, very highly visible diagnostic LEDs and display for you to always know what's going on with your scanner. This is a performance level D safety laser scanner, highest performance level that's able to be achieved by a safety laser scanner just due to the type of technology it is. And it also is a 275-degree scan angle. So if we look at this from the top, that gets you from about this point all the way to this point. So we can actually see behind the scanner, which is very, very useful because if you put the scanner on the corner of a machine or a vehicle, then you have 2-sided protection. And in the terms of vehicle, to get 360-degree protection of that vehicle, we only need 2 scanners instead of 3 or 4. So that is, again, saving you on the number of sensors that you actually need on your machine. All right, so now I'm going to pivot to sharing my screen. I have a slide that I want to share with you here. Give me just 1 second. All right, hopefully you are now seeing the slide with the smart functions. Okay, so we do have 2 versions of the NanoScan that are available. There's a NanoScan 3 Core IO, which is typically geared toward more stationary applications and simple applications. This gives you 1 pair of OSSD outputs, up to 8 configurable fields and monitoring cases, and 4 simultaneous fields. With our Pro IO, which is geared toward more complex applications and particularly mobile applications, you get up to 128 configurable fields and monitoring cases and up to 8 simultaneous fields. So we can actually look at 8 different fields at the same time, noting that there's a max of 2 pairs of OSSDs on the Pro IO, meaning that we could have 2 protective fields configured, and each one of those protective fields has its own distinct safe output. So you could use one protective field for slowing down a robot or a vehicle, and then another protective field for actually stopping that robot or vehicle. And this is done all through IOs, nothing over safe network, just purely through IOs. We have individual field settings, meaning that those simultaneous fields that you're looking at can actually have different resolution settings. So maybe with one field, we want to have a 70mm resolution where we're looking at somebody's legs. But then with another field, we're a little more strict on what we want to look at, so we can set that to 30mm resolution or open it up to a larger resolution like 150mm, because maybe we're actually just trying to detect if there is a cart or something that's coming into the field. Another individual field setting that you can do is multiple sampling. Multiple sampling rate is the number of times the scanner has to actually see an object, has to scan an object successfully, or successively, excuse me, and successfully, to register it as a valid object that will shut down the safe output. The default and the lowest setting you can have is 2 times multiple sampling. But in an application where you might have a lot of dust and dirt or debris causing false trips, you can increase that multiple sampling rate anywhere from 2 up to 16. Now, the higher you set that, the more likely you are not to detect those things falling through the field, but it's going to increase your response time. So with these individual field settings, you could actually have one field that has a really low multiple sampling rate that's detecting people that are coming into the hazardous area, and will very quickly shut down those OSSDs or the safe outputs. But on a field that's very close to the machine or the vehicle, where we're more apt to have debris falling through the field, we could set that field at a higher multiple sampling rate. So now we have the best of both worlds, where we have a fast response time for somebody approaching the machine and the hazard, but we have high availability and high robustness versus false trips closer to the vehicle. As I've already mentioned, navigation data is included. So you really have 2 sensors in one with safety and measurement data navigation. And then contour detection fields. This is something that's really unique. So contour detection fields, you can actually set a contour, just draw a contour really in any shape that you want the scanner to recognize. And when that contour is recognized by that field, you'll get a safe output out of the scanner. So you could use that so that the scanner can recognize different situations or different applications that it might be in. I like to use the example of an AGV or an AGC approaching a charging station. So you could use a contour detection field to recognize when the vehicle is coming close to that charging station, and then change the scanner behavior as well as the vehicle behavior based on what the scanner is seeing. Now I'm going to switch over to my visualization and diagnostics tool. So this is a tool that can be used to grab data out of the scanner so that you can see the measurement data of the scanner as well as the configured fields of the scanner and the current monitoring case. And one thing you'll know here is if you look toward the bottom middle, we have a duplicate of that LCD display that's on the scanner. And what it's showing us right now is a little, looks like a hand with a cloth and a spray bottle. So this is telling us that we actually have a certain level of contamination on the scanner, and we need to clean that. It's not so much contamination right now that it's shutting down the scanner, but it's at a threshold where it's saying, you know, this will become a problem eventually. So if I just reach down here and wipe off the screen of my scanner, now you notice that as soon as it catches up with me here, it'll just go green. So now it's saying you no longer have a contamination issue. Everything's good. So we want to always tell people, you know, what's going on before it leads to downtime. So this is just an example of some enhanced diagnostics you get. With this visualization and diagnostic tool, I don't recall if I mentioned, but this is a free tool that you can get from SICK. So it's a really easy to use batch file. It's not an actual software that you have to install. It works on any Windows-based PC or HMI, except for Windows CE, unfortunately. But any other Windows operating system, this will work on. It's just, like I said, it's a batch file that you just, you take that file, you put it on the PC or HMI that is connected to the same network as the scanner, and then you just run the file and it automatically pulls up this data. So you can see here right now at the bottom here, it says I'm in my medium monitoring case. So that means the vehicle's going at a medium speed. If I slow the vehicle down, it will then change over to my slow monitoring case. And you can see now we have different fields. So these fields shortened up. And now we have this funny looking field in the middle here. This is actually a contour detection field that I've set up to look at myself. So let's see if I can get into the correct position here. There we go. So now the side of my body here, this is actually my hip because I have the scanner down at hip level, is seeing me standing in the proper place. So the scanner is green because I have set it up to trigger the safe output of the scanner. But if I step away and I'm no longer in that field, as I move out there, you'll see that the scanner then goes red because that contour is no longer being made. Some other things you can see here, there's an information tab where you can get, if you have configured a project name and or application name, it will tell you that here. So this is all information that would be pulled out of our safety designer software. That is the software that's used for configuring the scanner. So I want to make sure not to confuse what we're looking at here with the configuration software. This is purely a visualization and diagnostics tool. The software used for configuration is Safety Designer, and that is also a free download that you can get off the SICK website. We do not make you register. We don't ask for any information. You really can just go there and download it and install. You see the name of the device here, the type code, the serial numbers of both the scanner head and the system plug, checksums of the configuration. Again, this is all information that can be output over Ethernet and sent to a PLC or to an HMI of your choosing. But it's just this visualization and diagnostics tool is a nice quick way to get that out of the scanner without having to pull that out yourself through the data output settings on Safety Designer. Another really cool thing is the event history tool. This is also something that you can use in Safety Designer. An event history tool, the scanner actually saves the last 150 events that caused the safe outputs to go low. And that's always saved in the scanner. It's first in, first out. So if you've gotten to 150 events and then you have another trip, it'll just kick out the first one and save the newest one. And when you connect, all you do is you hit update and it pulls all the latest trips out of the scanner. And you actually get measurement data for the last 30 events that caused a trip. So if I click on one that's within the last 30, it will actually show me a snapshot of that measurement data so that I have an indication of what happened. Now I'll give you some examples of how that's useful. If you have debris falling through a protective field, you will just notice something show up in the middle of the protective field and then just disappear. That's a very good indication that you have something that's falling, debris falling through the field. If it's somebody that actually is walking in or an object or a person that's causing the scanner to trip, you'll see something much like this where it's a solid object that just happens to move and go into the protective field. And often then will go out again. I like telling the anecdote of there's a major automotive manufacturer in Germany that bought a bunch of microscans when it first came out back in 2016, and we had this event history tool available then as well. Well, they were really frustrated with the scanners because they were getting a lot of false trips on one scanner in particular every day. They're very upset. We said, hey, let us come in, take a look and see what's going on. First thing we did was look at the event history, since that is always readily available. And you could actually see from the measurement data just the shape of two legs kind of walking into the protective field and then right through. And this is happening during the same period of time every single day. So they were able to very quickly determine that there was an operator on that machine that just didn't really understand how the scanner worked in the field that it was looking at, and that if you walk through this area, you're going to stop the machine. So then they were able to take that person, give them some extra training, and after that, we're very, very happy with the performance. So just a really nice and easy way, if you do find yourself having false trips, that you can go in and identify exactly what's going on, and then ultimately remedy the situation. Let's see. One other thing I want to point out on this screen is that you also, on the bottom right here, will see the status of those fields. So you can see this right now, I am not in the contour, so it's saying that cutoff path is closed. If I go into the contour, that will change to green. Or if I stick my hand down in one of the protective fields, then you can see that both the safety slow and the braking slow fields were stopped as well. So here we are utilizing those dual OSSD outputs. So actually, if I change this to a fast speed, you can see we changed to full speed here. As I walk in, we trip the warning field, and then I will hit the braking full speed. So this would slow the vehicle down. But then if the object stayed there and didn't move, then once we hit that second protective field, then we would hit our safety stop. So very flexible in how you use the multitude of fields that you have available to you. So yeah, that is all I have. So I think then I can open it up to questions.
Thank you so much, Tyler. This is great. I love this little guy. He's so cute. We've got some questions coming in. First one is, how many variants of the NanoScan 3 are there?
Yep, so there are two variants. There's the NanoScan 3 Core IO, which just gives you fewer configurable fields and monitoring cases, as well as just one pair of OSSD outputs. And then there's the Pro IO, which improves upon those things. But then with each core, with the Core and the Pro, you have the option of either having that Ethernet connection or not. So in all actuality, it's two performance packages, but really four different choices that you have to make.
Okay, cool. Just wanted to make sure, because I know I get confused sometimes.
Sure.
And then we have an interesting question. Can you mount the NanoScan 3 upside down?
Yes, excellent question. So just like with the MicroScan 3, you can mount the NanoScan 3 upside down. So I'll flip this over here. So this is how somebody might do this. We see this on vehicles a lot, on AGVs and AGCs, because it just tends to work better for tucking it up into the chassis of the vehicle, and then have the screen poking down, looking out. What's really nice about doing this is with 6 scanners is that screen right there, so you don't ever have to kind of crane your neck or stand on your head to see what it's reading or to see what it's saying. As within the Safety Designer software, you can click a little checkbox that says rotate display 180 degrees. So that display will actually flip around and read right side up for you, even when the scanner's upside down. Another reason that we would look to potentially mount these upside down is in dusty or dirty applications. The contamination sensors on this scanner, so before I showed you how it can tell you when there's contamination, are actually built into the collar of the device. So they look up at the screen. And so if the device is like this and dust accumulates on that collar, you will get a contamination warning, just as you would if it got on the screen here. When you mount it upside down, you pretty much eliminate that chance of dust getting on the collar. So you're likely going to reduce, and you're kind of shielding the screen here too. So you're going to reduce the amount of times that you're having to clean that screen.
Awesome. A little easier for those dusty, dirty applications you have.
Absolutely.
And then this is another great question. Can you use the NanoScan 3 outside?
Yes, another very good question. The NanoScan 3 cannot be used outside, or I should at least say it's not rated for outdoor use. But we do have an answer for that. So last year, the Outdoor Scan 3 from SICK was introduced. This is actually, it was the world's first, and I believe still currently the only safety laser scanner that is rated for outdoor use. And that's thanks to a new technical specification by IEC, which is IEC 62998, that SICK was able to, we actually sit on that standard. So we knew it was coming down the pipeline. So we were able to, in parallel with that standard being published, develop the outdoor scan. So yes, for all of your outdoor safety needs, look to the Outdoor Scan 3.
Okay, so not this one, but we do have another option.
Exactly, and what's nice is the Outdoor Scan 3, just like the NanoScan and the MicroScan, they're all configured with Safety Designer. They all use the same exact configuration principles. So if you know how to configure and use one, you know how to configure and use all of them.
Awesome, easy enough. And then we have a much more specific question. So can this laser sense the difference between like a body, I guess that means like an object, and polymer melted glass, so, or melted gas. So it's saying, this customer is saying that they're having some of this melted, like the polymer is making it false trigger on their other sensor. If it's a little more complicated than we have time, you know, you can generally answer, and then they are in the question box for you if you want to type one out.
Okay. Okay, perfect. Yeah. So yeah, to answer that accurately and specifically, yeah, I would need to get more details because they're, you know, with the safe EandM scanning technology, we are able to filter out, like I said, you know, debris and things falling through. We're able to differentiate against ambient light and crosstalk. So it would depend on the nature of that, and you know, if it was something that's flowing through, if it's a solid. So I would need to get more details. So I can't really say for sure one way or the other. Okay,
so a little more complicated. We can, of course, have you ask the customer more questions in the Q&A, or we can also get them to pass their information on to us, and we can help them at a later date as well.
Sounds good.
So that's all the questions I have right now. We have about 2 minutes left. So if anybody else has any questions, let us know.
That's actually perfect. On that last question about the gas, I think it's interesting that SICK's current generation of safety scanners is really using an advanced form of time of flight technology. This is not your father's time of flight, the HCDM, safe HCDM that Tyler was referencing. In my opinion, it has the highest chance of not false triggering in those more complex situations where you have thick gas and so on. But not knowing any more details about the specific case, you know, the best thing would be to look more closely at it. One of my favorite feature of the NanoScan 3 is the contamination and dust detection, that it knows when the optical window is getting dirty, but also the icon used to tell you that is a nice bottle of Windex, Clean Me. My car does that frequently, but anyway, yes. So thank you very much, Tyler. That was a great presentation.
Actually, Andrew, that's actually a really good. Just very quickly before I sign off here, I want to point out that we do actually have a SICK, a cleaning solution that SICK sells now. So in the past, there's always been one on the website, but was never set up for sale in the U.S. because we couldn't get it imported from Germany just because of the nature of the solution. And actually within the last month or so, we have a solution that is set up in the U.S. So we can work on that. And if anybody out there wants a solution to clean the screens on your scanners or other optical devices, you can just ask EandM and I'll make sure they have the information.
Awesome. There's an official cleaner. Great.
Yes.
Awesome. So